The question we are solving now belongs to test series 1. It is of network theory subject. In specific, it belongs to sinusoidal steady state analysis. As per the question, there is a magnetically coupled circuit given as shown. In this, the coil 1 has an inductance of 0.2 Henry and coil 2 has an inductance of 0.4 Henry. The dot convention is as shown and the resistance in the circuits are 100 ohms. Please note that the mutual inductance between the two coils is 0.2 Henry and also the mesh currents through the circuits are I1 and I2. If the circuit is operating at an angular frequency of 1 radians per second, we need to find the ratio of the phasors I1 and I2. So we can find the ratio of the phasors I1 and I2 by applying mesh analysis to the second mesh. So upon applying the same to the second mesh, we see that the drop across the 100 ohm resistor can be written as 100 I2 plus the drop across the 0.4 Henry can be written as J1 0.4 multiplied by I2. But please note that the drop we have mentioned just now is the drop due to self-inductance. There is a drop across the coil 2 due to the mutual inductance as well, and this corresponds to the mesh current I1. And this drop is given as J multiplied by 0.2 multiplied by 1 multiplied by I1. But the problem is we don't know the sign of this drop. Please note that for obtaining the sign of this drop, we need to use the dot convention. As per the dot convention, a current entering the dotted terminal of one coil will produce a positive voltage which is sensed positive at the dotted terminal of other coil. From this logic, we see that the current I1 is entering the dotted terminal of the coil 1. Hence, the voltage drop due to the mutual inductance will be sensed positive at the dotted terminal of the second coil, and the polarity will be as shown, and the magnitude of the drop is J multiplied by 0.2 multiplied by I1. So from KVL we see that this can be written as minus J 0.2 I1 is equal to 0. This upon simplification can be written as I2 multiplied by 0.4 J plus 100 is equal to I1 multiplied by 0.2 J. Upon simplification, we see that this can be written as I1 by I2 is equal to 0.4 J plus 100 divided by 0.2 J. So upon division, we see that this can be written as 2 minus 100 divided by 0.2 J. So this upon simplification becomes 2 minus 500 J. From this we see that the ratio of the phasors I1 by I2 can be written as 2 minus 500 J upon using the dot convention and the KVL. Hence we see that the correct option corresponding to the ratio of the phasors is D.